Welcome to Math with Mrs. Cox. We are on Chapter 2, Lesson 1, Prime Factorization. We will begin on page 85. If you followed me along with me in the guided practice, you should be very familiar with factor trees. But let's quickly review. 42. Need to find a couple of factors, and because it is even, the easiest thing you can do is chop it in half. So divide 42 by 2, and if you're unfamiliar how to do that, you can do the old-fashioned way of going like this. 2 will go into 4 twice. 2 times 2 is 4. 0, bring down the 2. 2 will go into 2 once. 1 times 2 is 2. 0. So we know that it's 2 times 21 will be our first factor, and that 2 is prime. Here they just have you bring them down. I like to circle them because then it makes it easy to find and amongst all your work, especially when you have work like this. It's easy to find your factors because they're circled. All right, let's begin, shall we? Find the prime factorization for each number. Please use your multiplication chart if you wish. And you know what? You probably can do this faster than me. So see if you can beat me with it, shall we? All right, let's start out with 50. 50 is even. I'm going to divide that thing right in half by 2 times 25. 2 is prime. And then 25, I have 5 times 5. All right, now we need to write this from littlest to biggest. So I'm going to go 2 times 5 times 5. All right, 81. Common factor for 81 is 9 times 9. Makes our little factor tree. Now 9 is not completely prime, so we need to break that down even further. And I know that 3 times 3 equals 9. So I can do 3 times 3 over here. Circle them because they are prime. And I'm actually do it from least to greatest, which doesn't really matter because they're all the same number. Ta-da! Okay, 65. 65 is a little bit trickier. If you look on your factor, your multiplication sheet, you're not going to see anything that equals 65. So kind of what you do is you start playing with some different numbers. It is not even. So you can try dividing it by 5, or you can try dividing by some other number, because 5, because it ends in a 5, usually 5 should go into it. So let's try that over here. Let's do 5 into 65. 5 going to 6 once. 1 times 5 is 5. 6 minus 5 is 1. Bring down the 5. We have 15. 5 will go into 15 3 times. 3 times 5 is 15. So then our answer, our factors are going to be 5, which is prime, and 13. So is 13 prime, folks? Can anything go into it? You're right, it is prime. So write it from littlest to biggest. We have 5 times 13. Easy peasy lemon squeezy. All right, 28. If you look on your times table chart, you'll figure out that 4 times 7 are some factors for that. That is prime. This is not. It can be broken up into 2 times 2. Okay, write it from least to greatest. All right, flip over to page 86. Brittany scored an 85 on our last math test. Write a prime factorization for 85. Okay, 85. So let's look at this for a second. It's not even, so we can't divide it directly in half. Oh, as I move the camera, sorry about that. But there is a 5 right here. So I'm betting we can do 85 divided by 5, shall we? 5 will go into 8 one time. 1 times 5 is 5. 8 minus 5 is 3. Bring down the 5. 7 will go into 35 7 times. Well, excuse me. Don't you just love when I get the answer? 5 will go into 35 7 times. 7 times 5 is 35. Okay, so there's our two factors. So we can say 85, the factor tree, is going to be 5 times 17. And write it from littlest to biggest. And that's our answer. Ooh, brain builders, love them. Priscilla has 56 stickers in her collection. Write a prime factorization for 56 and explain how you know the numbers are prime. Okay, so 56. Okay, that number is even, so I know that we can at least divide this in half. So I'm going to do a little divide sign right here. 2 will go into 5 twice. 2 times 2 is 4. There'll be one that'll come down, bring down the 6. 2 will go into 6 at least 8 times. So 2 times 8 is 16. Okay, so I know, I'm gonna do a little 56 over here. I know we've got a prime factorization tree, 2 times 28. 2 is prime. Okay, 28 is another story though. What can we do with 28? I know that 28 is even. So I'm going to try that again. 2 will go into 2 once. 1 times 2 is 2. 0, bring down the 8. 2 will go into 8 4 times. 4 times 2 is 8. 14. Okay, so then I can do 2 and 14. And I know 14 is 2 and 7. So that makes my life a little bit easier. And they are prime. So prime factorization from littlest to biggest, 1, 2, 3, and then a 7. Okay, we did our first one. Now explain how you know your numbers are prime. Well, prime means only one and its self can factor. Whew. All right, find the error. Laney, not our Laney, of course, wrote the prime factorization of 60 as 2 times 5 times 6. Is she correct? If not, what is a prime factorization of 60? Well, let's see what she gets. 2 times 5 is 10. So then you have 10 times 6, and that makes 60. Right? 2 times 5 is 10. 10 times 60 is 60. If she's not correct, explain why. Okay, the book says no. Book says no, she's not correct. She used 6. Oh, I see what's wrong. So this is 60. So it does make 60, but she is not correct because look at this. Can that be factored down a little bit more? Yes, she needed to factor it down. So if we did 60 and broke it down, I would do 2 times 30. I'd cut it in half. And then I would do 5 times 6. And now 6 is not prime. It can be cut in half. It can be cut down. 2 times 3. No. Here's the correct answer. 1, 2. So there's going to be 2 times 2. And then we have a 3 as our next number. And then a 5. There we go. So yes, that makes 60, but it was not the correct prime factorization. That is the correct factorization right there. Make sure you get primes in that, okay, folks? All right, vocabulary sentence. Composite and prime is what we're looking for. Fill in the blank with the correct term or complete the sentence. Blank numbers can be written as the product of blank factors. This is called prime factorization. Ooh, so which number are these babies right here? These are the ones that only one in itself can go into, so they are, yep. We need prime over here and the word composite. Composite numbers are like this little 6. It can be cut down by a ninja. And prime means that they have been broken down as far as they can be. Good job, friends. Test practice. Josiah had a potbelly pig as a pet. Oh, that would be an interesting pet. It weighed 46 pounds. What is a prime factorization of 46? It's even, so let's divide it in half, shall we? If I do 46 over here in the margins and divide it by 2, 2 will go into 4 2 times. 4, bring down the 6. 2 will go into 6 3 times. 3 times 2 is 6. So if I divide that in half, I'm going to have 2 times 23. Now I'm pretty sure 23 is prime because I know 2 won't go into it, 4, 5 won't go into it, 6 won't go into it. So do I see that answer over here somewhere? Yep. Now remember, to decide if that's prime or not, you're looking to see if a 2 will go into it, then you try a 3, a 5, and a 7. If none of those numbers will go into it, then more than likely it's a prime number. All right, friends, turn this into your homework tower, and thank you for your time.